Hello, Tom from Every Step Calculus, EveryStepPhysics.com. You can see the problem on the screen. A spacecraft is orbiting around Jupiter, and they're asking for the period of the spacecraft's orbit. Period is the time the spacecraft goes around one revolution around the planet. One thing that I want to say about my programs, is that you came to this site and other sites probably online because your professor didn't teach it right, didn't teach it at all. It showed up in the practice test, and you checked your book, physics book, which was worthless, and you couldn't find the answer, so you came. Now you found the answer. Here's the quick, concise, step-by-step answer to this problem and a million other problems that you have in physics. If you are lucky enough to purchase my programs for $30 and load them into your titanium calculator and allowed to use the calculator in your test or homework, and you'll pass the physics class. Now these classes are scored on the class curve and the partial credit, okay? Anything you can throw down on a test, you get a few points for. That's relevant. When I was in physics, there's some problems I couldn't put down anything, and whatever I might put down there would look like a complete idiot. So then therefore I started to program on the calculator at that time and was lucky enough to find that system to be able to do that, and I'm the only one that does it now, including the TI site and anywhere else you might want to look. It's the only way you can get this into the titanium is under my system. So think about that. Let's do the problem here. Physics to get to my main menu. I've already scrolled down through the whole menu. The main menu of mine is always what a problem asks for. For instance, if it asked you for tension, you'd go to tension. If it asked you for momentum, you'd go to momentum. If it asked you for, in this case, period, of course, you're going to go to planets, because anything you have to know a certain thing about my programs that I have to think about how I'm going to group these things when I program. For instance, if you saw bullets in a problem, you'd go to bullets in my menu, even though it was trajectories and all the rest of it that is involved with bullets, certain things like that. But most of the time, if they're asking for acceleration, you go to acceleration. If they're asking you for tension, you'd go to tension. If they're asking you for momentum, you'd go to momentum, okay? Well, anyways, we're going to go, this is all grouped under planets. Anything with spacecraft or satellites or orbits or planets is all under the heading of planets, okay? You press enter. Next thing comes up is what they're asking for. We've had planets, now we're asked for the period. We're going to scroll down here to the period, and here's period. Okay, we're going to press enter on that. And then what's next comes up on my menu would be the variables that are given. Well, in this case, the radius of Jupiter, 3 times the radius, and the gravitational acceleration on the surface of Jupiter, 24.5 meters per second squared. Now, one more thing about gravitational acceleration on this problem, just for future knowledge. And I'm not teaching. I like to show you how to do these problems, but sometimes you need to memorize a couple of things to know how to do it. In other problems that I've researched or that I find would be gravitational field, okay? And these are all trick little sayings. I don't know why professors do that, but this is really the force of gravity on the surface of Jupiter is 24.5 meters per second squared, okay? That's the acceleration, gravitational acceleration on a planet. In ours is 9.8 meters per second squared on Earth, okay? On Mars, I think it's around like 3 meters per second squared, less or whatever. But anyways, I ask you that. I try to help you as much as possible because these problems have little different words in there, and the professors love to do that to screw you up on a test or screw you up and see if you're really, really smart like they are and like the other nerds in your class that are supposedly so smart about things, you know. So anyways, we're going to scroll down here to, here's radius and times and gravitational field, okay? So I mentioned gravitational field because this is different. This is gravitational acceleration. But even gravitational field is really the force of gravity, okay? So we're going to go down to number 6, or you can press the number before it. I'm going to press number 6. And I always show you the formula, try to show you the formula, because that's what the first thing you're going to write down on your test paper. 2 pi times the r and v. Now, r is the radius of Jupiter. If it was a capital R, it means orbital radius, okay? So I try to help you with that too. And so now we're going to enter the radius of the planet, okay? So we press alpha first. It goes 6, 9, 9, 1, 1. And it's in kilometers, so make sure you see that. We have to scroll up to kilometers or press number 4. And I do the conversion for you. You can write it down, the formula for the conversion, if you want on your paper. You look like a genius. Now we're going to enter the times factor that they give you. Well, it's 3. So we're going to press alpha 3. And here's what I'm talking about with the given the gravitational field or acceleration, okay? In this case it's acceleration, so we choose that one. And I explain it. It's exactly the same as the force of gravity, the term used in Earth, and the SI unit is meters per second squared, okay? Now we're going to enter the gravitational acceleration or field. I'm going to press alpha 2, 4.5. I have to go slow because of the simulator. And I show you what you've entered. And this all looks good to me. You can change it if you want. I say it's okay. And we do the calculations. You need the orbital radius, which is the times the radius of the planet. And turns out to be this. We ask for the velocity. Well, that's the square root of the orbital radius times the force of gravity on Jupiter. And here's the answer. And then we get the answer. What we're asking for is the orbital period, what they're asking for. So we put 2 pi times RV, which is here, right here. These variables are entered, and here's the answer. Now, that's always in seconds. Everything's in seconds when you're in these functions or problems, equations. And then I divided down here. You can get minutes, hours, days, months, or years. Well, here's 0.21 days. You're 5 hours. It takes this satellite spacecraft to go around Jupiter. That's really traveling fast because Jupiter's a huge, huge planet. Okay? So anyways, go to my site, buy my programs, and pass physics if you want. Otherwise, just suffer and try to study this stuff yourself. I can't see any reason for doing that, you know, especially at the cost of these programs. So, but you have good luck in your class and have a good one.